Hello, I'm Dr. Harper. This video is in project management and this is a homework video. This video will go over homework number 3, PMBOK, the quantitative methods. So let's bring up the homework assignment. In this homework assignment, I start with just the knowledge areas in the quantitative areas, project schedule management, and this is just reading them right off of the definitions in PMBOK. Question 2 is the cost management in the different processes in the quality management, and this talks about project quality, and then risk management, and then procurement management. So those are just definitions out of the off the lecture and out of the book. So what I will cover though is the latter part down here, the quantitative parts. And well, the second part here I talk about first just the definitions, then I go deeper in some of the techniques. Okay, then I get into the quantitative methods, and now this right here I talk about the quality control charts, and this is there's the video on the website under process control charts. We'll walk through this step by step, so I won't cover that. But some of these, like in question 11, to conduct the conduct procurement vendor selection, this technique is a very popular technique, and I want to start with this because so many people misuse this and do it incorrectly. Sometimes they have approximately right, a heuristic method that's right, but I'm going to show you a method that is mathematically sound, that's easy to defend, and it gives you consistent, reliable results. Okay, but instead of working this, I'm going to work another problem, which is like this, and you'll just take these values and put them in the template. So let's bring up Canvas, and in Canvas, down here I have my website. Where is it at? Here it is, mdharper.com, my website. Go to the website under Project Management. Then you come down through lecture, material, PMBOK-1, PMBOK-2. If you come further down here, Word files, PMBOK-2. Here's an Excel file for procurement, MCDM, and that's that problem. So if you download MCDM, right-click and then open in a new window, that's going to download it. Let's open this up. There it comes. So let's open this up. Don't need that. Enable editing. Okay, let's bring it back. Let's minimize this. Okay, so essentially to work this problem, and notice I have the same criteria: technical approach, management approach, past performance, prices, and we have a weighted criteria. And then in the proposals A, B, C, D, E, you'll have measures in here. And I say higher is better, and they're all from 0, I think 0 to 100, I think is what I said. It doesn't matter. Whatever they are, they're positive. So the conditions that you require here is that these values are positive, higher is better, and they're ratio scale. So ratios matter. Okay, well, let's bring back Excel. Let me show you how to work that. If you bring down this template that I have, and let's open up full screen. I go through actual lecture and show how to do it because a lot of people do not really have seen this. Okay, let me go through this real quick. Consider the example of criteria, weights, alternatives, and measures. Here's your criteria. Here are your weights. And notice 30, 60, 70, 80, 90, 100. These are your alternatives, proposals 1, 2, and 3. And these in here are your measures, or your measurements. Okay, check for conditions met. Conditions require positive measures, and they're all positive, and that's positive. 0 doesn't count, negative doesn't count, only positive. Ratio scale, we're assuming the ratio scale. And then higher is better for all measures. Okay, but then when we look at all the conditions, everything is satisfied except technical approach. This is higher is better, higher is better, higher is better. Price, lower is better, because usually the lower the price is better. You don't want to pay a higher price. You want to pay a lower price. And so this one needs to be reversed. It needs to be reversed from lower to higher. Well, weights and measures are positive in ratio scale, but price is lower is better and needs transformation. So you replace price with a reciprocal, and that's why the ratio scale. With the ratio scale, the inverse will be the reciprocal. So essentially what I did here, if you notice here, I just take 1 over the price, and then 1 over the price, 1 over the price. So now all my conditions are met. So now I'm going to take these measures and actually have a weighted score, but I'm going to standardize it and I'm going to normalize it. That way all the conditions are easy to interpret and reliable. So the conditions are met. So let's come back, move over here to the right-hand side, and here is the actual procedure. So let me walk you through this on how this is done, because when you have alternatives like these proposals or whatever, when those alternatives are relatively close together, you need a technique that's reliable, consistent, and something you can argue meaning defend. Okay, so I brought that back up. Here's my weights. Here's our weights, and here's our measures here. Number 1, sum. You sum the rows, and you sum these rows right here. So you sum the rows. Now these sums indicate the relative bias, and you want those sums to be equal. Well, notice it goes from 93 to 170 to 219, and way down to 10 to the minus 5th. Okay, and so the way you take this bias into account, there's a number of ways to do it. The easiest way in Excel is to take the weights, divide by the sum, and get modified weights, and that's exactly what I did. So 30% divided by 219 is 1.3699%. Okay, and this is percentage the 20%, 0.2 divided by this really small value turns out to be 3,614. So we are standardizing everything to a common scale, and if you don't, then you have a bias. Okay, and notice, so therefore I have an unbiased weighted score. And if you notice what I do here, I have a sum product of these values times the modified weights. Same thing here. I have these values times the modified weights in a sum product function. And then I do the same thing here. Okay, now I sum these up, and notice the sum of all those is 100. Now, I mean 1 or 100%. It's not always that's not always the case. This sum right here will always equal this sum of your weights. In other words, sometimes you don't have weights. Sometimes you have the weights may not sum to 100%. And you say, oh, well, that's not good. Well, it doesn't really matter. What matters, since it's a ratio scale, what matters is that these weights relative to one another have a ratio scale. So it doesn't matter if they sum to 100, but if they do, whatever sum that is, then that's going to be 1. For example, suppose this is 0.1. Okay, well, it sums to 90%. So, but then that's an unbiased weighted score. It's unbiased because of the modified weights. Let's put this back to 20%, 0.2. It's unbiased. But then to normalize it, I divide through by the sum so that I force the sum to be 1. In other words, if this was a 0.1, notice the sum is 90%, or 0.9. And these numbers are not the same. Okay, I divide through by 0.9, and I normalize them to 1. So these sum to 100%. Now, the normalization really is not essential because all you care about is the ordinal relationship of the ratio numbers. Higher is better. And so once I normalize, whether I normalize it or not, proposal 3 is going to have the highest score. This is an unbiased score. It's a normalized unbiased score. Oh, I said proposal 2 is the winner. Proposal 3 is the winner. I need to change that. Interesting. I had the wrong one there. Proposal 3 is the winner. And and what I do here, I just do these if statements. If this equals the max of these, then I'll say yes. If it doesn't, I'll leave it blank. So you can see here that proposal 3 is the max. Highest score? Yes, number 3. So proposal 3 is the winner. So this is how, let's bring this back down. This is how you would solve this problem. And basically, all you do is just take these values right here and just do exactly what I did. Okay, and that'll solve that. That's the quantitative approach to solve this. But also, it's a very valuable thing to know using the MCDM because it's used in business everywhere, not just projects. Almost any organization where there's a decision to be made and a lot of information, a lot of criteria, and all those criteria have to be satisfied. Usually, people just do it by judgment. But if you're in government, or if you're going to be presenting it, or you're going to have scrutiny, or you're going to have a peer review, you have to have some kind of a defendable situation. Okay, let's go on. The project management here. Okay, now then, EVA. A company is preparing a report of the earned value analysis for the end of March. Aha, end of March. There we go. Let's like that. I like this dark thing. Where'd it go? Over here. Let's make this maybe a 1, and then let's just 1.5. In other words, end of March is when the EVA is. At the end of March, the actual cost is $8,500, and the percent completion of the activities are. The percent completion of activities is. Okay. Everybody has a strength and a weakness. Is that right? Is that right? The percent completion is, or I don't know. Everybody has a strength. I probably shouldn't be saying this on the videos, but my strength is quantitative. Sometimes. Okay. And then the percentages are 100%, 100%, and 40%. Okay, there they are. And so you come down here. Which letter indicates the correct results of the EVA at the end of March? Okay, and you notice what I have here. Interpreting the schedule. Is it on schedule, ahead of schedule, behind schedule? Interpret the budget. Is it on budget, under budget, over budget? At completion, what is the project time to completion at completion? And one of these is right. At completion, what's the project cost estimated at completion? So this is doing the EVA at the end of March, and not only determining if it's on budget, the schedule and the budget, it's also predicting a future, estimating the future on the time and cost. Okay, well, this is doing an EVA, and so let's go back to the website. My website here. Now down here you have procurement, but if you come back up here, let's see, here's PMBOK-2. If you come back down here, I have an Excel file. Here it is, Excel file for the EVA. So you download the EVA, you open this thing up, and wait for it to open. There it is. Okay, now you can just enable editing here. Let's enlarge this. So you can pretty much use this. Now, in other words, you can, this value here, you can put, this is 12.5. You can put 5,000 in there, and it just changes all the numbers. 12,000, 8,500, whatever. This is 12.5. Okay. When it does this, it changes all the numbers. So that's the actual cost. Now these right here need to be, let's bring this back down. Whoops, don't want that. Don't want that. Here we go. So you take these right here, Control C and copy them, and I just did. Okay. Then you come back to here and you Control V and paste them in. And then you put the right cost. Okay, and then at the end of March is when they're doing this, and then this will do all of it for you. There you go. Okay, and notice the earned value is going to be this number over here. The actual cost is pulled down from up here. That's input. The planned value is the sum of these at the end of March. The sum of these planned values, and from those three values and the total planned value and the time of completion of the project, then these can be calculated, but they'll calculate for you. If you put in the times here, the planned values, and you put in the actual cost. So, and then you interpret it. You can interpret it with the indexes. I think the indexes are easy to interpret. Let's make this bigger. Okay, cost performance index is 0.8. This is below 1. So a bad cost means you're over budget. If the index is greater than 1, then you're under budget. Okay, and the schedule performance index is 1.25. It's above 1. That's good. That means you're ahead of schedule. If it was less than 1, that means you're behind schedule. Now, if the cost performance index is 1, schedule performance index is 1, then it would be on time, on budget. Okay, and so I'll leave that for you to put those in and then solve that. Okay, and then the next one, let's see what's next one. Estimate your costs. Okay, here all I'm doing is just going through giving you this equation, and so just estimate the cost and sum them up. That's all you do. So right here, you take this. Let me make another and just say column 4. And then estimated cost. I don't know why that did that. Let's see what's going on here. Okay, let's just do this. I'll just cheat here and do this. Bingo. Okay, and then center this thing. There we go. And so all this is doing is saying, okay, I'm going to use this equation where the normal cost is the normal here. That's most likely, and just calculate it. Okay. In other words, I could take this, Control C, come over here, bring up my, I had a blank Excel spreadsheet. Oh, there it is. And then come down to here and Control V, paste this thing in, and there it is. Make sure it's numerical, and then enlarge this thing. And all we're doing here, okay, is I don't want to let me put a number in here. Okay, let me put a 100, 200, 300. Okay, and so that's not there. So what's going to be? So that's going to equal. Well, that's symmetric. That's not fun. Let's make 100, 200, and let's make this 500. Okay, so it's skewed. It's skewed to the larger side, the pessimistic side. So the mean, the average, is going to be more than 200. So you do the normal, 4 times the normal. Whoops. 4 times the normal plus the optimistic plus the pessimistic. And since I have 6 numbers in, 4, I don't want 4. 4. I pushed 8 instead of star. Anyway, 4 times the normal, most likely, times the optimistic, plus the optimistic, plus the pessimistic. And there's 6 numbers in there. 4 of these, 1 and 1, that's 6. You divide by 6. Okay, so it's going to be 183.3 and a third. So the idea, and if this was 600, this probably would be, it's going to be a whole number. That's 200 then. Let's do 500 again. Okay. And okay. Unfortunately, this is 100. This should be 200. The normal cost optimistic has to be lower than the normal. Whoa. How about that? Okay, my optimistic is going to take longer. No. 200 is a cost, is estimated. 100 is going to be the optimistic, going to be less. 500 is a pessimistic, going to be further, more cost. So there you get the 233 and a third. There's more than 200. It just didn't feel right, did it? Okay, and so that's kind of what we're doing. And once you get this, you take this, and then you copy it all the way up and down for the right numbers, not these. Then you copy that, and then you sum it. You sum all these numbers in from here all the way up to here, and there you go, and that's your answer. Okay, that's that one, and that's just going through that equation. Just having done it, you'll remember that there's it's a weighted mean. It's a weighted mean, and this is a weighted mean that's used in PERT. It's also used in cost estimates too. Okay, because the most likely or the normal cost is a higher probability of happening, assuming like some type of a normally normally distributed distribution. Okay, not a normal distribution, but no. Then earned value. We'll come back to EVA. What are we doing here? Oh, on this one, 5 projects are being evaluated using earned value analysis. According to the EVA values, which project possesses the best overall performance, assuming higher values are better? Now it's overall performance. And what I mean by overall is both the cost performance index and the schedule performance index. So let's bring a couple of these things over. So let's do a cost performance index, and let's do a schedule performance index. Okay, and we don't need all of it. Let's just center this thing. There we go. Okay, and so basically you're calculating these things out. Is all you're doing. Okay, and so again, you can take these, Control C, bring our Excel spreadsheet back if you want to use Excel. I think it's a good thing to do. Open another sheet. Come down here and paste. Control C, and then make sure the numerical. Make this thing bigger. And so basically, let me put an F in there. Again, I don't want to steal your thunder. Let's have a number that's not there, 20. And let's have a number that's not there. Let's say 400. Okay. And then the earned value. Okay, here we go. The cost is a $400,000 project. And let's suppose our earned value is 250. Okay, and a number that's not here. The actual cost is 230, and this is 260. There we go. And so you take the cost performance index, okay, and that's just simply going to be the earned value divided by the actual cost. And then this is going to be the earned value divided by the planned value. Okay. Okay, then you take this and you copy that for all the rest of them. The idea here is like this is above 1, this is below 1. So this is higher. So the cost, the budget is in better condition than the schedule. And so which one of these has the highest with the cost and the schedule both high? And so you can look at this, it's just comparison is all it is. Again, it's just getting used to recognizing the results of an earned value analysis. It's pretty fundamental. It's not, there's a lot more to EVA than this, but this is just the first introduction. Okay, let's go on to the next one. The project schedule management, the AON, analysis on node. AON is given right here. And then it's comparing a network to the actual definition down here. Here's project definitions. So it's just recognizing it. For example, 1 here is the first project, so there's no predecessors. 1 is a predecessor of 2. 2 and 1 are predecessors of 4. It's just recognizing this and then saying which one of these, A, B, C, D, are correct or none of the above. So it's just matching it up and just recognizing the activity on node network. Okay, now CPM. You have come to a planning meeting where the network is being discussed of an upcoming project. The network given below and the duration in weeks for each activity is provided in the table. So they give you the duration, but then they give you the AON, the activity on node. So which is the actual time of completion of the project in weeks? What's the time of completion, the TOC? Well, what you do here, let me go ahead and put this in here, copy this over and expand this out a little bit, is okay, let's bring it to the left. Boom. Okay, the different paths. Okay, and so basically you take the paths. Well, we see here one path is A, B, E, G. A, B, E, G. Okay, well, what's another path? Well, we have A, B, then it comes down to F, then comes up to G. So we have A, B, F, G. Okay, so for each one of these, then you take the actual values up here, the times, and determine the times. A, B, E, G. A is 1. B is 3, E is 3, and G is 6. And I add them up. 6, 7, 8, 9, 10, 11, 12, 13. That's 13. I do the same thing for every path through the network. Okay, and then when you're done, then you say, what's the time of completion? Well, the time of completion is going to be the maximum time of every path through the network. So this question is emphasizing you have multiple paths through your network in your project. There's all different things going on at the same time. What do you look at? You look at those activities that are on the path that has the longest duration, because if any one of those is delayed, the project's delayed. Now, if some of these are on a path that is not the longest, then some of those can be delayed. But all the activities on the path with the longest should not be delayed, and that's called the critical path. And those are critical activities. Okay, so this question 16 is highlighting it. Then question 17 is actually doing it. Okay, this is calculating the critical path, etc. Okay, so here what we're going to be doing is, let me just do this. Let me see if I can put a bunch of these out there. Bing, 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 bing. Okay, we have the activity, predecessors, and durations. What do we want to calculate? First is the early start, then the early finish, and then the late start, and the late finish, and then the slack, and then the critical path. Is it on the critical path or not? Because up here, what we want the critical path. We want all these activities that's a critical path, and they want the time of completion. We don't need these anymore, so we get rid of them. Okay, so now, once you've got to build this table, and once we build the table, then we can pull off the time of completion of the project, which is the longest path, and it will give you the critical path, all the activities on that critical path. Okay, well, how do you do that? It's a lot of work, but let's go back to the website. Hello, website. Here we go. Here's our resources. I come back to the same under PMBOK-2. I come down here. Here's time cost. This is good right here. Time cost, I think. Let me see. I've done a lot of these, so many things here. I'm showing you which ones I think will fit with this homework assignment, because these apply to different applications. But for this introductory course, this would be good, I think. Open, here we go. Oh yeah, this would be a good one. This is a real good one. So essentially, here's your critical path method. So notice the CPM, here's the house in the lecture, here's the PERT, and there's the earned value analysis. So everything is right here. I could have just had this for the EVA. But anyway, let's enlarge this. Here I only have 7 activities, and you may need to, let's see here. You may need to expand this. Where's the problem? Here it is. Oh yeah, we have 15 activities. So what you want to do is you need 15 of these things. So let me go ahead. What I suggest, you copy this over, CPM over, there it is. You copy it over, now I have a copy here. I need 15, there's 7, shift plus 7, 8, 9, 10, whoops, sorry, control plus 7, 8, 9, 10, hello, escape, boom, 8, 9, 10, 11, 12, 13, 14, 15. Okay, in other words, we're going to take these activities right here. Let's go ahead and take them right here. Control C, and then come back to our Excel spreadsheet. Okay, let's put it in down here. Let me just put it down here. Control V and paste. Control C, and let's come up here. Well, let me, I'll put it right here. And transpose it. Okay, Control C, make sure it's numerical. Now, here's my definition, and up here, I want to take my activity is 1 through 15. My predecessors are here, and my duration is here, and duration is here, actually. So let's take the predecessors. Let's take all of the predecessors. And there they are. Control C. Back up. Here's my predecessors. Put them all right here. All 15 of these. Boom. And this is going to be 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, and there they are. Now my durations are given here. And so I'm going to take all my durations, all 15 of them. There we go. Control C. And then bring this. I could have done it actually from, I should have done it just from the Word file. But then here's my 15 here. Control V. To make sure they're the same, this duration must be the same as this duration, and then copy it over. Make sure they're the same all the way to here. And there they are. Okay. And now what you're going to be doing is calculating these early starts, these early finishes. Oh, I should have done that. Bring it back. These early starts here, the early finishes is going to be the same equation. Is just go through the early starts with the predecessors. Okay, and once you have that, and notice these late starts will all be the same too, you can copy that over all the way to the end. These you can copy this all the way to the end. So you have half of it already set up. But then the late finishes here, delete, you're going to have to put these in depending on your solution up here. Okay, and then you build it. Then you just put it in, build it. So this is going through the CPM example with all 15 of these, going through at one time. And once you see how it's done, then this is for setting it up and then analyzing it. So this course is not really a production course, it's analyzing projects. You set it up and then we can analyze. Then we're going to analyze it in subsequent weeks. And we'll start analyzing these different projects. Okay. And so you start with 3 here. These are 0, 0, 0. And I just hung up my, there we go, 0, 0, okay. And then this is 2, so this is going to equal my second one. Here's my activity 2. And then this is going to be the max of 1 and 4 of 1, comma 4. This is max of 2 and 3. 2 and 3. Max of 3 and 5. 3, comma 5. And this one is just 6. Equals 6. Okay. And then you do it on, you just do it for the rest of them. Okay. And then you'll have it there. Spin this down a little bit. Yeah. Okay. And actually over here, the right actually give you the expression, the function. But then the time of completion, now remember these are not right, equals the max of all the early finishes. Remember that's how we did it. So this is not right because I haven't finished this out here. But if that's the time of completion, then you come down here and you have to create your successors. Okay. And the way you do that, you just invert this table right here. Let me go ahead and box this in. And I suggest maybe shade it in a little bit so you don't get mixed up. Okay, here's your successors. So you come along here and looking at activity 1. Activity 1 is a 1 and 4 is a predecessor to 5. That means 5 will be the successor to 1. Okay, so come down here on 1 has a successor of 5. And then you come across here 2. Where's all the 2s? There's a 2 there, and there's a 2 there, which is 4 and 6. So this one is 4, 6. Okay, and then 3. Where's a 3? There's a 3 and there's a 3. Aha. Any other 3s? No. So 6 and 7 right here. 6 and 7. Okay. And then 4. 4 is, there's a 4 here, which is a 5. 4 here, which has a 9. So it's 5 and 9. 5 comma 9. So this is this. So once you get all these successors in here, then you can. Well, let's keep going until we get no successors. Let's see. Number 5. 5. There's going to be 1 here. I think that's it. So that's a 7. 6. There's a 6 and a 6. 8 and 9 and a 13. So this is going to be 8, 9, and 13. Let's see here. 7. Is there a 7? Yep, there's a 7 right here. Any other 7s? No, and that's a 12. Good. What about 8? Yep, there's an 8 here and an 8 here. Any other 8s? No. So there's a 10 and 11. So there's a 10 and 11. Okay, 9s. I'm hoping to get to, okay, 9. Is there a 9 here anywhere? Calling for 9. 9, hello 9. No. That's what I was waiting for. 9 has no successors. I hope I did this right. I don't see a 9 in there anywhere. 6, 4, 6, 8, 7, 6, 11, 13. Nope, it's nowhere. Okay, then I go on. I'm not going to do the rest of them. So now, to get the late finish, if you have no successor, this will equal the time of completion. Now, this is not the right time of completion, but this is how you would do it. And then once you have the time of completion, then you go through, okay, here the successor is 5, so this will equal 5 right here. Actually, tell you what, let me do. Let's take these activities right here and just copy and put them right here, because these stop at 6. Well, I guess I could just finish them at 6. 7, 8, 9, 10, 11, 12, 13, 14, 15, because I need these activities here. Okay, here it's 5. So this is going to equal the late start of 5. See, 5. Boom. This is 4 and 6. So they equals the min of 4 and 6. Well, here's 4, comma, 6. And there we go. And this is 6 and 7. So this equals the min of 6 and 7. So here's 6 and 7 will be these two right here, the late start of those. And then here's equals the min, whoops, min of, what was that? What is that? Can't see it. 5 and 9 equals the min of 5 and 9. Here's 5, comma, and way down here is 9, late start. Boom. Then that's just 7. 7 is right here. And then here's 3 of them. Equals min of 8, 9. Oh, I can't see it for that. 8, 9, and 13. So we have 8, comma, 9, comma, and 13, return. And then you just keep going. Okay? And when you get done, you have the time of completion up here. You'll have the slack, which you can copy this over too. Okay, and notice the slack here. I took the late finish minus the early finish. You could have taken the late start minus the early start, doesn't matter. But that's going to be the slack. And so that's kind of what they're looking for, the slack of all of these values. Okay, so when you have a slack of 0, then that's your critical activity. So the question is asking for the time of completion, and it's asking for the critical path. And so once you get this done, you go through it once, there's a time of completion right there. And the critical path are all these activities down here with a slack of 0. You collect the zeros and you do that, okay? Now let's back up. One thing in passing, a lot of people have asked this. I really didn't do it in this spreadsheet, but usually, see, this is an activity on Node. A really popular graph to present things is a Gantt chart. And really all you need is the early start and the duration of the Gantt chart to get the Gantt charts. That's all you need. In other words, if you highlight this, come up to Insert, come over to Graph, come down to 3D, do a horizontal, and do a stacked. You click that thing, and so this is really your Gantt chart after you edit it. Okay, first you want to get rid of the blue. So we'll double click that. They're all highlighted. Come over here. Under the fill, we want no fill. Under the border, we want no line. And so boom, there's our Gantt chart, but it's in reverse order. Actually, let's format this a little bit. Let's make that dark, and let's make this dark just to highlight it. Now this is in reverse. It goes 7, 6 to 1. We want to reverse that. Well, you can reverse that pretty easily. Double click, and under the over here under the axis options, categories in reverse order. Click that. Boom, and there's your Excel spread. There's your Gantt chart. Let me say Gantt chart. You can put that in there. You don't need the legend, okay? And then you can edit these. So he says, well, those are nice, but I'd rather have, I like the solid fill, and make the solid fill be like a gray, maybe a little darker gray. Okay, and then the border, a solid line, and make the solid line black. And there you go. Okay, and then you can come up here and you can edit the axis and the grid lines and do all kinds of stuff. In other words, let's reduce this down a little bit and put this over here. So I really didn't do Gantt charts. This you have to do by hand, but this can be done very quickly, no matter how big your project is, and you can generate Gantt charts pretty quickly. Okay, let's go on. That's the critical path method. We're getting to the end here. Oh, now we get into the PERT. Now the PERT is probability, okay? And so 5 projects, and so I ease into the probability part. 5 projects are part of a program where risk of project delays is being evaluated as one significant criterion. Select the project with the greatest probability of exceeding 530 days. Completion time, that is, the probability of the time of completion is more than 530. Well, here it is. And I say note, I even tell you that the probability that the time of completion is greater than some t, which is going to be 530, greater than or equal to, greater than with a normal distribution, same thing. Doesn't matter, it's identical, is 1 minus the normal standard distribution of the z-variate, where the z-variate is the t, in this case 530, divided by the expectation of the time of completion, divided by the square root of the variance of the time of completion. So t minus the expectation divided by the standard deviation. And then the normal z is the function in Excel. Okay, well, let's do it. Let me just show you how this is done. Once you have this number, in subsequent weeks, we'll be using this table and analyzing the table a lot and saying, okay, and here's where you start designing projects. But let's first start with this. Control C. Let's bring our Excel spreadsheet back, and this time, well, I have PERT over here. Let me just open a new page. Let me put this in here. Control V, Control C. Make sure it's numerical, and let's make this large right here. Now remember, the t that we wanted was 530. Okay, and I'll just equal that and just bring this over. That's what we wanted. And these are the numbers up here. Now, I don't want to, again, steal your thunder. No, 530. Notice this is 524, 25, 26, 27, 28. This is 530. I want to change this number to show you how to do it, but then you have to go through and actually calculate this thing. Okay. Let me change this to 5, something in the middle. How about below down here? Nah, let's take something more interesting. 525.5. 525.5. How's that? Okay. And let me change the variances down here. Let me just change it. Let's say 100. 90, 80, 50, 30, 50, let's say 40. Okay, let me just change them around like a little bit. So what you do is get your z value. Okay, well that's going to equal the t minus the expectation divided by the square root of the variance. And there it is. And then you copy this over, all four, and then you get the probability. And that simply will be 1 minus the normal standard distribution. And all it wants is the z, which is the z. But when I do a dot s, I say, I want the cumulative, which means I sum it up till that. 1 minus that will be greater than. Okay, and I'll say 1 for cumulative. So there it is. I can copy this over. It should switch. Yeah, it goes from 0.4 to 0.5 because 50, it's right in the middle here. So I want 525.5, and it's right between these two. So this jumps from 0.4 to 0.5, more than a half. So this is the probability of time of completion greater than t. Okay, so that's what we have. Whoops, I don't want that. Interesting. There we go. And so right here, it turns out that this is the greatest. That may not be true for your homework assignment. So once you set this up, all you got to do is put these numbers, get the right numbers in there. Okay, but that's how you work the problem. Okay. 19. Okay, let's see on 19. Oh, upload one PDF file consisting of a Gantt chart of the project, a discussion of the expected time of completion, and the probability of time of completion exceeding 270 days. So now we're doing the Golden One project, and doing this, we will be using this Golden One project in the next couple of homework assignments. And so let's look at this. Let's go back to the website. Let's see here. Let's come down to PERT. Let's see here. Here's a PERT down here. Here's a PERT. Let's see here. Is there a PERT up here? See which one you like best. Here's a cost. Excel file. Here's an Excel file, CPM PERT. Let's open this and see. Let's see what this looks like. Came over here. There it is. Don't need this anymore. Don't need this anymore. Okay. Okay, for PERT, here's PERT. Enable editing. Okay, and I have 7. Again, I have 7 activities here. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll have 9. So I need to expand this by 2. Okay. So the difference between PERT and CPM, it's minor differences. And so you're given these values here, and you're giving the predecessors. Okay, let's bring this back and see. So I give the 3 estimates here, and then I give the actual predecessors here. Okay, so you go through, you take these 3, and there's those 3 estimates of the mean. The equation is given over here. And then you take the variance, and the equation is given here. Okay, so you have the mean and variance, and there you go. So once you have this, then you take, notice you take the mean, the expectation, as the duration, and at this point, this right here is nothing more than the critical path method. That's all it is. So this can be put into the critical path method, or just copy it over and put it here. Okay, so that's the critical path method. So there's a time of completion right there. And notice activities 1, 1, activity 3 is 0, activity 6 is 0. So 1, 3, and 6 have a slack of 0, so that's my critical path, 1, 3, 6. So then for 1, 3, and 6, I bring down the mean and variance for activities 1, 3, and 6. Okay. Why are they 1? Yeah, that shouldn't be 1. Okay, these are probably, let's bring this back. I guess it is. Oh, okay, I get it. Yep, that's going to be a 1. And that's going to be a 1. Yep, it's going to be 1. Okay, now, for the 1, 3, and 6, to get the time of completion, I'm going to add the 3, I'm going to add 5.2, 2.6, 3.4, 11.2. And notice that's the time of completion, 11.2. But at the same time, I add the variances. 0.25, 1, and 1, I get 2.25. Okay? Why do I need this? Because now that I have, bring this down here. I see I didn't do it here. I should have done it here. Let's add. I did it again. I did a shift plus instead of a control plus. There we go. Let's bring this down to here and then equal this and bring it over like this and then copy it down. Now the reason I'm doing that is because to get the z, see I did it, but I did it right here. And let's see here. To get this z, I'm using this one. Anyway, so to get this z, it's going to be the t minus that divided by the square root of that. That's pretty much what I did. Okay, and this is probably more informative. So essentially, to get the minus 1, 4, 6, 6, 7, I take equal. I take the t minus 11.2 divided by the square root of 2.25. But since I have that, for each one of these, I'll just copy that over, and notice the numbers don't change. Boom. And then I calculate the probability of less than. This is less than. And so then I'm taking the norm.s.distribution of the actual z, comma 1. And this is going to be the same. Copy this up. Those numbers don't change. But the reason I do that is now we can calculate any probability. I can put any probabilities in here, any times in here I want. It'll give me the probability. So let's say 11.2. What would 11.2 be? It'd be 50%. Boom, 50%, because that's the time of completion. Anything less than that, the probability of being earlier is lower than 50%. Probability of being later is going to be less than something later is going to be more than 50%. Less than or equal to 12, well, you get a 70% chance of doing that. So I'm expected to do it in 11.2 time periods. But if you go more than that, the probability is going to be greater. I mean, what's it probably going to get it done? If it takes a day to do, what's it probably going to get done in 10 days? It's pretty high. Should be anyway. Anyway, if we're probably of getting it done in less than a day, well, the probability is going to go down to get it faster. And that's exactly what this is saying. Less than that, 9 and 10, it's going to be less than half. More than 11.2, it's going to be more than a half. Okay. Then 1 minus that, if I want the probability of the time of completion greater than t, then I simply just take 1 minus this. 1 minus that. And there's a probability of greater than that. Okay. So the probability of greater than 12 is 30%, approximately 30%. Okay. So this is probably probability of being late, 12 or more. Okay. And then this is a probability of being early, 10 days or earlier, it's 21%. This is 7%. Okay. And so future, I think this is what's being asked. 270 days. So this is not the same problem, but I put 270 in there. That's what I was getting at. 270. Well, this is the different problem. Okay. So then you would put 270 and you'd have the probability right there. They have these probabilities, and from that you answer the problem. Exceeding 270 would be this probably down here, greater than. Okay, so that's how you solve these things, and so going through the work, that's a procedure, and notice it didn't take too long to go through it once you have it, but you have got to pay attention and do each of the details. So you do this once, and save the files, because we'll be using these files and build on them on subsequent weeks. So this is how you the quantitative part of analyzing this homework. As a matter of fact, what I should do, what I think I'll do, is Control C, bring this over here, bring it up here, bring it down here, and then where's A, B, and C? Yeah, I think this is it. Control V. Yeah. There we go. 1, 2, 3, 4, 5, 6 rows. Okay. So if you bear with me here, 1, 2, 3, 4, 5, 6. If you bear with me here, let's take this up here and let's go up here to the top and put it right there. Okay. So now I know I need 2 more rows. I need 2 more columns here. So I'll say 1, 2. Okay. I'll bring these back. And then let me take these A through I and put them here. So this is how you would do it. And then I'm going to take all of these times, comma, Control C, and put them here. Control V, and there they are. And I almost got them all in there. I just have to do this last 2. 1 and a 2. And there you go. So there's the means and the variances. Okay. So then I come back down here, and now I take the predecessors here. Okay. I really don't want 2 rows. Let me see how I can get rid of this. There we go. Predecessor, let me take this right here, Control C, and bring this down to my predecessors. And there it is, all the way to there. And there they are. Let's get rid of these. Okay, now what I want here is the durations. This right here is going to equal ET. And then copy this over. There you go. And then early start here, this is 0. This is 0. Okay. Now remember, these are just going to be the early start plus the durations, and copy that over. You can do that on all of them. Okay. And by the way, okay, and let's delete this for now. This is 0, 0. This is going to be A. Oh, let me take these off. Let me put the right ones in there, so I don't get confused if things are floating around here. Is there more down here? Nope, that's about it. Okay, where was I? Here I was. Here was I. Okay, ready. This is A. Equals A. A is right here. Equals A. A is right here. Equals B. B is right here. This is B. See? CD. Ooh, okay. Equals max of CD. Well, CD is going to be these 2 right here. Bingo. D is just going to be this. And then this is going to be E. E is going to be this one. And this is G and H. So this equals max of G and H. G and H of these 2. Okay? And then the time of completion equals a max of all the early finishes. Okay, I got 258, and I actually think that's right. Okay, now then, these right here will be dangerous. We don't want those. Successors, we have to generate those. Slack is going to be the same. That's not going to change. But then the duration is going to be the same as this duration. Copy that over. There you go. Okay, now we have to get our successors. Okay, and so we have these predecessors and successors. We have to just invert this file. Tell you what, let's take the successors up here, and let's just move it up here, and then we'll move it back down. Let's see here. Move these up here, move this down here. Get your workspace organized, center. Okay, now A and A. Oh, let's center all of these. Okay, here we go. We're going to do successors. A and A. It has C and D. So A has C and D. Okay. B here, predecessor B. B is a predecessor to E, which means E is the successor to B. Okay, so B has E. Okay, what about C? C here has F. Okay, so I'll put an F. What about D? Well, D has two of them, F and G. So we'll have F, comma, G. Now, what about E? E, where's E? Yeah, E has H. So for E, I'm going to put H. What about F? E. B, C has F, D has F and G, E has H. Now what about F? There is no F. Oh, okay. So there's one terminal activity. What about G? Yeah, G has I. Actually, G and H has I. Is that all? Yep, G has I, and H has I. I can see that. G and H both have I. And then what about I? I is nowhere. So that, now, do I have them all? I don't know. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. Quality check. Got them. Okay, now I'm going to take the successors back down where they belong. And there's my successors. Bing. And I'll move these predecessors back down. Oh, I can leave them there. Don't need them. Okay. So here's my successors, and there they are. And let's box those things in. Okay, now I'm going to generate my late start and late finish. Okay, where there's no successors, the late finish here is going to equal the time of completion because nothing is after it because there's no successors. It's at the end of the project. So the late finish is going to be the time of completion. Now remember, the late start is always equal to the late finish minus the duration, and just copy that over. But now we have to fill in the late finish for everyone else. Okay, so CD equals the min of C and D. Okay, C and D is going to be these two right here. Oops, did not want to do that. C and D is these two right here, which are going to be those two. So this is E. Actually, before I do this, let me bring the activities closer to where I'm looking at them, you know. Okay, there we go. And then center those. Okay, now we want E. E is this. Now I want F. F is this. Now I want F and G equals min of F and G. There's F and G right there. And then I want H. H is this one. Then I want I is this, and this I is this. And there I'm done. Now these slacks, I've already done the slacks here. It's going to be the late finish minus the early finish, and then copy those over. Okay, and then let's bring this down. And let me say critical path. CP, oops, critical path. And I like to do this just because if I start looking, it's easier for this Excel to do this. Equals if this equals 0, comma, then if it's true, then I'm going to say yes, comma. And then the second expression, if it's false. If it's false, I'll do 2 quotes, which is a blank. Okay? And then just copy that over. So I can say I have 1, 2, 3, 4, I have 4 critical paths. So I take the activities here, I put them down here, and there's my critical path. Now, remember, let me take these out. Let me bring these down. So this equals my early startup, my expectation. Where are they? Right there. And then copy this down. That's the variance. And then I'm going to copy this all the way over to the very end. Okay? Now what I'm going to do is say, okay, all I want is my critical path. So these two I will delete. These right here are not critical, I will delete. These two are not critical, I will delete. That's critical, and there they are. Okay? So now right here, this is going to equal the sum of all the early of the means, and that should be 258, and it is. And this will equal the sum of all of the variances. I'll go ahead and do all of them. And that's 275. Interesting. That's my variance. So now down here, here's my t. Let me say 250. Okay. Now, since 250 is less than 258, my z is going to be negative, and there's my probability. And notice I can say, what was the problem? I wanted 270. Actually, all I have to do is just put 270 in here. And then that's going to be, those are the probabilities for 270. And that's how you work the problem. And I've worked it all except putting 270 in there. And you can see these numbers here. To make sure you get these numbers, I'm pretty sure this is right. For everything. Okay, so there's all my numbers. Okay, so I've worked this problem for you, number 19. Well, this is going to be important because we're going to be graphing this more. We're going to be doing a lot of things with this. And so hopefully everyone will be able to do this. And I encourage you to do this, even though I've done it here. I encourage you to do this to make sure you know how to do it and get the file set up, because we'll be using this file later. And I'll be working it for you later, but we'll be working it together. Okay. And let's see here. Do I have a Gantt chart on this thing? I don't know why I'm taking so much time on this. I apologize if you're getting bored. Yeah, no, I didn't. Okay. So what I need is the early start and early finish. Where are they? Here's the early start and duration. So this is what I need right here for all my activities. So I take my activities. Let me just take them up here. Control C, put them right here. Center. A, B, C, D, F, G, H, I, and the duration. And then say Control. And then come up here, the insert. let's just go ahead and make a Gantt chart with this. Real quick. Fill, no fill. Border, no border. No line. And then over here we want to, there we go. We want to come to here and categories in reverse order. And so essentially we want to paint to where the solid fill is going to be a gray, solid line is going to be black. And then let's just make this, format this to have a box and a box. And there's my Gantt chart. Okay, so I'll be asking you to do more and more of this. Actually, I think I asked you to do this. I did ask you to do this. So that's how you do it. Gantt chart. Okay, so the way you do that, for those of you who are new to this, suppose I want to put my Gantt chart in there. I can copy the Gantt chart, but I'll highlight it, and notice here that I've highlighted it. Come up to Home, Copy as Picture, as shown when printed, OK. And that's going to go into the clipboard over here, and there's the graph. OK, and it's a picture. So you move it out of here, and so here's my Word file, and this is your Word file. And so you want an explanation here. So let me just come to the end here and just insert another page. And so right now what you're going to be doing then is here you're going to have your text, okay, blah, 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 like this. And then you want your graph in there. So up here under Home, under the clipboard, just pop your graph in, and there it is. Then over here on the right, I like to have the text to be having control of the graph. So now I can move this graph around anywhere I want. So that this is the lower right. Otherwise, it'll move everything around it. And you can reduce it, etc. This kind of thing. And then once you have your Word file and you produce your Word file, and then come up under the File, Save As, and please title it here, and then save it as a PDF. And then you click that, it'll save it as a PDF and save. So I ask everyone to do that because the PDF is much more transferable when it's going, when it's being transmitted. The bits and bytes are easy to transfer. Okay. Okay. Well, I tell you what, that's enough for this lecture. I just get into it, and it's so much. Once you get into it, it's fun. And I should have quit a long time ago. Or I should have gone faster. Sorry it's so long. I'm not sorry. It was long. I hope you're still with me. It's been a while now. But anyway, this is the end of this homework 3, and that's how you work it. And so, and you have the templates there and the Word and the website. Make sure you use those because they're there for you to use. So good luck for this weekend. Next week, if you have any questions, I have office hours Monday, Wednesday, Friday at 7. And so make sure you do come and ask questions. And if you have any questions on the material, let's bring up the Canvas again. Notice in traditional quantitative, what I've done here, I'm learning how to do this because anyway, click the Q&A, and this Q&A then will have questions. No one has posted any questions. Put the questions here. Often other people will have questions that can answer your questions. Okay, and I think didn't I put something in here? Yeah, you can attach your file. Attach your file. Have people share your file, share your answers, collaborate. I encourage collaboration. I was hoping people would use this, but now I have a question and answer for this topic. If you want to ask questions, post them here and answer each other's questions. And I will look at this. And for now, I'm going to start saying, if you have a question, post it on the Q&A in Canvas, and I will answer it so everyone can see the answer, so that everyone can share answers. But when I share an answer with you, that answer will be shared with everyone else. Okay. And so there's that in the in the traditional quantitative, and I'll be doing this every week now. So this is where Q&A is going to be. Okay? And then I have office hours right below it if you want to talk to me personal about it. Okay? So I'm trying to streamline this and make it efficient. So hopefully this helps. I hope this helps. Between now and the next time I see you, I want to tell everyone, don't take anything for granted. Be safe out there. Take precautions and take care, because I want to see you again.